Alright, so in this video we go over section 7.3 trigonometric equations. Um, just like polynomial equations, logarithmic equations, so we can solve equations involving trigonometric expressions. Well, those equations are going to be looking slightly different than, well, not the equations, but rather their solutions and the way that we solve them. First of all, what we do is to determine whether a given angle is a solution to a given equation. And again, all you want to do is plug in this number wherever you see, well, not in this case, not x, but rather theta. So I'm going to go to sine theta, which is pi over 4 minus 1, and check whether that equals to 0. Using the unit circle, sine of pi over 4 is square root of 2 over 2 times this 2 minus 1 equals to the 0. Is that true? Well, square root of 2 minus 1, that's not equal to 0. So this is not a solution. Alright. Okay, what about pi over 6? Well, so 2 sine of pi over 6 minus 1. So sine of pi over 6, you're using the unit circle, that's 1/2. And in this case, cancel these 2's and we're left with 1 minus 1, which is 0, or 0 equals to 0. And in this case, that is a solution to the equation. Alright, how are we going to solve equations? Well, so in order to solve this trigonometric equation, so first of all, well, let's look at some kind of the easier cases, the ones that do not require yet the use of a trigonometric identity or solving something something very fancy. All right, so let's see. So what we're gonna do here is, well, for cosine theta equals 1/2, so we're looking for the angle theta whose cosine equals 1/2, and we, in a way, we already did this when we did inverse trigonometric functions. But well, inverse trigonometric functions had restrictions, and in this case, for the equations, we're going to look at this in a slightly different way. So for example, okay, let me draw a Cartesian plane. All right. And well, recall the ASTC. Okay, that's going to tell us the signs of the trigonometric function. So in this case, we want cosine to be a positive value. That means that in this case, well, we're going to have cosine, it's positive in the first quadrant. So cosine is related to the x coordinate, and also over here 1/2 common root of 3 over 2. All right, and the related angles in this case are going to be, well, pi over 3 and 5 pi over 3. All right, well, these are the solutions, but we are also asked to find the general formula for the solution. This was a little typo here. We don't need that. So what about this? Well, because for example, this one is going to be a solution, but keep in mind that trigonometric functions are periodic. So if I add 2 pi, that's another solution, and then add 2 pi again, we get another solution, and so on and so forth. Same over here, 5 pi over 3. Add 2 pi, you get to the same point, different angle. Add another 2 pi, and so on and so forth. So that means in this case, well, actually, I need to highlight something for, in this case, well, theta on the one hand is pi over 3 plus 2 pi k. Well, this k represents the multiples up to pi. And on the other hand, theta equals to 5 pi over 3 plus 2 pi k. Alright, so in this case, these are going to be our general solutions, the general formula for the solutions. From here, we're going to input values of k. For k starting at 0, so that's theta equals pi over 3 plus 2 pi times 0. Well, that's going to be, well, simply pi over 3. So that's one solution. For the second angle, k equals to 0. Theta equals to 5 pi over 3 plus 2 pi times 0, which is simply 5 pi over 3. Alright, that's another solution from the second. Okay, so now the thing is, well, in this case, I could stop here and say that the two solutions are pi over 3 and 5 pi over 3, because ultimately what we want is all the solutions in the interval 0 to 2 pi. So, but in this case, you might want to verify, and we're going to do this exercise later in other equations in which we would need to do. In this case, we don't need, but I'm going to show you what essentially we do. So theta equals pi over 3 plus 2 pi times 1. Well, in this case, to add the fractions, I need 3 and 3 for the LCD. Final answer, 3 times 2, which is 6, plus 1, that's 7 pi over 6. On the other hand, 5 pi over 3 plus 2 pi times 1, and then 3 over 3. And well, I need 3 times 2, that's 6 plus 5, that's 11 pi over 3. But in this case, this is what's going to happen. I'm going to disregard these two solutions. And the reason for which I would disregard these solutions is because these two solutions, 7 pi, well, actually, that's 3, 6 times 3, that's 18, that's a 19, not 7 actually, that's and actually over 3, not 6. So these two solutions are outside of the 0 to 2 pi 0 to 2 pi range. So the only solutions to these equations are pi over 3 and 5 pi over 3. All right. Let's look at another example, an example in which we are going to solve for the trigonometric form first. So 2 cosine theta equals the square root of 3, and cosine theta equals the square root of 3 divided by 2. Okay, so we are going to look for the values for the angles for which cosine equals to square root of 3. That is the x-coordinate in the unit circle. And we also want it positive in this case. So let's find out. All right, so cosine is positive in the first and the fourth quadrant. All right, again, so this is another cosine equation. So in this case, the x-coordinate root of 3 over 2 and root of 3 over 2, but in this case negative 1/2. All right, so the angle whose cosine is square root of 3 over 2, or actually the angles are going to be, in this case, well, that's pi over 6 and 11 pi over 6. All right, so that means that the expressions for the solution, so that's going to be, on the one hand, theta equals pi over 6 plus 2 pi k. All right, where k is an integer. Again, we're going to do multiples over here, and theta equals to 11 pi over 6 plus 2 pi k. So the general expressions or the general formulas are going to be the general formulas for the solutions are going to be these two. So now we're going to start doing k equals to 0. And well, for k equals to 0, theta in this case, pi over 6. Plus, well, plug in 0, you get 0. That's simply pi over 6. And then theta equals to 11 pi over 6 plus 2 pi times 0. Well, that's simply 0. And that's simply 11 pi over 6. And I'm going to do again the k equals 1 just to verify that the next solutions are out of the range. So you want to do that because sometimes you look at these numbers and then, well, this looks like the only solutions in the interval 0 to 2 pi. But what if for the next k, one of these two gives you an extra, and then you're going to get that wrong on my MATLAB when you do the homework. So you might want to do the extra step just to make sure. Pi over 6 plus 2 pi. Let me actually do the following, just so we don't get confused with the spacing here. All right. Pi times 1, that's the one right here. And well, when we combine these two numbers, that's 2 times 6 is 12 plus 1, that's 13 pi over 6, which in this case, of course, this is out of the range. Theta here on the other hand, 11 pi over 6 plus 2 pi times 1. So that's 2 times 6, that's 12 plus 11, that's 23 pi over 6. Clearly this number is disregarded because that's outside of the 0, the 2 pi limit that we want. All right. So the solution set, that's pi over 6 and 11 pi over 6. Final answer. Alright, let's look at another example. Let's see what we get. Alright, what about when we have sine of a multiple angle? You might want to pay special attention to this one. Those are going to be a little bit tricky to do. So let's see, how do we do? Well, number one, we don't have to solve for anything here because we have the trig function already by itself. So let's see. Let's do a Cartesian plane and look for the angles or the angle or the angles theta for which sine equals to -1. Alright, and it turns out that sine equals -1 only over here, right? So at -1 comma, or actually 0, 0, -1. That's the point, and in this case is 3 pi over 2. So there's, in this case, as opposed to the previous two examples, there will be this time only one single general formula. All right. However, the general formula, which will look something like 3 pi over 2 plus 2 pi k, but not equal theta only. In this case is the entire angle that it goes here, which in this case is 3 theta. So what are we going to do in this case? Well, so let's divide both sides by, or multiply by a third, or divide by 3, because we want to solve for theta. So in this case, go away. Theta equals to 3's go away. That's a pi over 2 plus 2 pi k over 3. All right, so that's our general solution, or the general formula to generate all the solutions. So in this case, I'm going to go first k equals to 0. So theta equals to pi over 2 plus 2 pi times 0 over 3. That's simply pi over 2. That's one solution. All right. Now let's do k equals to 1. Theta equals pi over 2 plus 2 pi times 1 over 3. Well, in this case, I'm going to need to find LCDs. Multiply by 3, divide by 3, multiply by 2, divide by 2. So, in this case, we're going to get something with denominator 6 and a pi. So, 2 times 2, which is 4, plus 3, that's going to be 7. Alright, so that's another solution. K equals to 2. Okay, let's keep moving. And so notice in the previous examples, k equals 1 was actually outside of the range. But in this case, because of the multiple angle here, it turns out that in this case, 3 theta makes a compression, giving us more solutions, in this case, within the interval 2 pi. I mean 0 to 2 pi. So theta equals to pi over 2. I'm going to leave a space for LCD. 2 pi over times 2 over 3. Well, in this case, what do we need? We need to multiply by 2, divide by 2, multiply by 3, divide by 3. Okay, so in this case, what are we going to have? Pi over 6. Let's multiply 2 times 2, which is 4 times 2. That's 8 plus 3, that's 11. And notice how 11 pi over 6 is very close to 2 pi. So most likely k equals 3. It's going to give us an angle outside of the 0 to 2 pi. But let's just do it just to make sure. So when you do the homework again, even if you're certain, I mean, just to make sure, just in case. 3 in this case, which is this 3. And so what do we need? 2 and 2. Well, actually, that's enough. So that's 2 times 2, which is 4. 4 plus 1, that's a 5. 5 pi over 2. And 5 pi over 2, that's a number that indeed is outside of that range. So we don't want that. So all the only solutions are going to be pi over 2, 7 pi over 6, and 11 pi over 6. So pi over 2, 7 pi over 6, and 11 pi over 6. All right. Let's do another one. Let's do one that has a tangent. That's going to be an interesting one. So let's see. So number 1, ignore the theta minus pi over 2. Focus only on the trig function and the value that gets outputted from the that we want to know in this case. So number 1, what I would like to do is first a Cartesian plane. All right. And we are going to look for all the angles in which tangent equals 1 and also positive. So it turns out that tangent is positive in first quadrant, right? Because root of 2 over 2, root of 2 over 2, all right? And it's also positive in quadrant 3 because negative root of 2 over 2, comma, root of 2 over 2. Okay, well, what about this? Well, because if you recall, tangent was defined as the y over x. That is root of 2 over 2 divided by itself. That's going to give us 1. Same here. Negative root of 2 over 2 divided by itself is also going to give us 1. So what are those angles then? Well, this is pi over 4 or 45 degrees, or on the other hand 5 pi over 4, which is 100 and I believe or 205, I believe it is. So in this case we need to write down 2 solutions. Well, however, keep in mind that it's the whole thing in parentheses that goes. So pi over 4. Alright, and this is theta minus pi over 2. But in this case, well, notice for the previous examples that involve sine and cosine, the periodicity in this case was 2 pi k because the function sine and cosine are periodic for every multiple up to pi, as opposed to in this case tangent. You want to be very careful. In this case, these functions are periodic at pi, multiples of pi. All right, so in this case, what are we going to do? Well, let's add actually pi over 2. And then we're going to get theta equals, well, pi over 4 plus pi over 2. Well, I need a 2 and a 2. That's 2 plus 1. That's 3 pi over 4 plus pi k. On the other hand, well, 5 pi over 4, theta equals to, actually, theta minus pi over 2 equals to pi over 4 plus pi k. And the theta will be, well, if I add just the same way I did it, oh, actually 5 plus pi over 2 plus pi over 2, and that's LCD, 2 and 2, 2 plus 5, that's a 7 pi over 4 plus pi k. All right, so that seems to be the exercise. That seems to be the two general formulas, right? General formulas. So let's go about k equals to 0. So if k equals to 0, this theta equals 3 pi over 4 plus 0, which is simply, because 0 times pi, that's 0, and then 3 pi over 4. Over here, that's going to be 7 pi over 4 plus 0, 7 pi over 4, k equals to 1. Okay, so for k equals to 1, something interesting is going to happen. 3 pi over 4 plus pi times 1. And then in this case, what is this going to be? 1 times 4, which is 4 plus 3. That's 7 pi over 4, which actually happens to be the same one as on the second generator, you know? So, and in this case, well, 7 pi over 4 plus pi times 1. That's the same, k equals to 1. 1 times 4 is 4 plus 7. That's 11 pi over 4. But in this case, we can tell that 11 over 4 it's a number way bigger than 2. 11 pi over 4 is bigger than pi over 2. So we can disregard this solution. Well, I'm not going to do in this case the k equals to 2, because the k equals to 2 over here is going to give me exactly this 11. This 11 pi over 4, which is not a legitimate solution within the interval that we want. So here, I'm just going to say theta, the solution set is going to be 3 pi over 4 and 7 pi over 4. All right, let's see what about it. What about the next examples? So, okay, so let's do one in which we are going to do some substitution here, because now if you look at this equation right here, we are going to require some algebra to simplify this one. Well, number one, what I'm going to do here is to do a substitution in which u equals to cosine theta. All right. So that means this is going to be 2u squared minus u minus 1, that equals to 0. And then, well, we're going to factor this polynomial. So using the diamond method, because the leading coefficient is different than 1, we multiply 2 times negative 1, which is negative 2, bring down the middle coefficient. And the factors of negative 2 that add up to 1 are going to be actually negative 2 and positive 1, because negative 2 times 1 equals negative 2, and negative 2 plus 1 equals negative 1. So let's see, 2u squared minus 2u plus u minus 1 equals to 0. Factor by grouping, 2u, u minus 1, plus u minus 1, and 1. You might want to have this 1 as a, just so you can see the last GCF, 2u plus 1, u minus 1. Alright, that equals to 0. And then once we have this factored out, let's do the following. Let's from here, u equals negative 1/2 and u equals to 1. But we need to back substitute for u. What was u? In this case, cosine. Cosine theta equals to negative 1/2 and cosine theta equals to 1. Alright. So now here in this case, well, we are going to be in the need of drawing two Cartesian planes. One for cosine. Oh, actually, this one's not what I was going to do. So on the one hand, I'm looking for the values of cosine, for the angles whose cosine is negative 1. That is, the x-coordinate is negative 1 in this case. Negative 1/2, comma, root of 3 over 2. And over here, negative 1/2, comma, negative root of 3 over 2. On the one hand, well, the angles that are going to be the good ones here, number 1, let me use a different color. So this angle right here is going to be 2 pi over 3. And this one right here is going to be 4 pi over 3. Okay, so 4 pi over 3. So I'm gonna do this one at the end. Let me first worry about these two. So let me go up here. Hopefully it's visible. Okay, let me just write for theta equals to 2 pi over 3 plus 2 pi k. Theta equals 2 pi over 3 plus 2 pi k. Alright, so those are the two solutions. So let me go about k equals to 0. Well, for k equals to 0, we're just going to get theta equals to 2 pi over 3 plus 0. That's simply 2 pi over 3. And then for the second solution, 4 pi over 3 plus 0 equals 4 pi over 3. Now let's do k equals to 1 and see what happens. Okay, so for k equals 1, theta equals 2 pi over 3. And actually, if you look at this, well, for 2 pi over 3, do one rotation, it's going to go past the 2 pi. But let's just do the calculation just to be sure. Let's not just rely on pictures, and let's do actually the math here. So 2 times 1, which is 2. 2 times 3, 6 plus 2. That's 8 pi over 3. And clearly 8 pi over 3, it's a number that is larger than 2 pi, so we can just disregard this one. Over here, 4 pi over 3 plus 2 pi. Well, add 2 pi for 2 times 3, that's 6 plus 4, that's 10 pi over 3. And clearly that's also outside of the range. So far we have these two solutions, one right here and one right there. But this is not done yet. Why? Because we need to consider the case in which cosine equals to 1. And cosine equals to 1, it's only true for the angle theta equals to 0. Alright, why? Because, well, 1 comma 0, the cosine value is related to the x coordinate in the unit circle. So in this case, for theta equals to 0. How are we going to express this one? Well, theta equals 0 plus 2 pi k. All right, and we can well reduce this to simply 2 pi k. So what are we gonna have in this case? 1, 2, 3 general solutions. Now let's do k equals to 0 and k equals to 1 for this. Well, for k equals to 0, theta equals to pi times 0, which is simply 0. That's good. But over here, theta equals 2 pi times 1, which equals to 2 pi. Well, this solution gets disregarded because that's actually equals to 2 pi. And for the solutions that we want to do, we don't want to include the 2 pi. Alright, it's just less than or equal. It's exclusive. Okay, it's non-inclusive for this type of questions. So our solution set over here, theta equals, open brackets, from smaller to large, well, this was 0, 2 pi over 3, and 4 pi over 3. Final answer. Okay. Let's do another example, but in this case we are going to do one that requires the use of trigonometric identity. So how so? Well, notice we have a sum of terms that have different trigonometric functions. Well, which trigonometric identity am I going to use here? Well, in this case I'm going to use the Pythagorean identity, the one that says sine squared theta plus cosine squared theta equals to 1. That's the one I'm going to use. How I'm going to use that one? Well, notice I have sine squared and sine to the first one, to the first power. So the best way to go about this is to convert this cosine squared in terms of sine. In other words, from here, cosine squared equals 1 minus sine squared. Alright, so I'm going to replace this over here where it says cosine squared. So 1 minus sine squared, which is basically this, minus sine squared theta plus sine. Theta equals to 1. Alright, I'm going to combine like terms. Negative sine squared theta minus sine squared theta, that's going to be negative 2 sine squared theta. Well, the power looks better here. Here it looks like a coefficient, but it's actually power. Plus sine theta equals to 1. On both sides, I'm going to subtract 1. Those are going to get canceled. Goodbye, goodbye. And that's going to leave us with actually, let's see, what did I do here? Never mind. So, negative 2 sine squared theta plus sine theta equals to 1. Oh, actually 0. All right. Okay, so how are we going to solve this equation? Well, so in this case, I'm going to factor out sine. Sine theta equals negative 2 sine theta plus 1, which equals to 0. All right. And in this case, let's see what are we going to get. Well, here using the zero product property, well, on the one hand, sine theta equals to 0 and negative 2 sine theta plus 1 equals to 0. We need to solve for sine theta in this part of the solution. So in this case, well, sine theta equals positive 1/2. And I believe we already did sine theta equals to 1/2. Let me verify that in a minute. Okay, so let me do sine theta equals to 0. So let me draw a Cartesian plane for this angle very simply. And well, sine theta equals to 0 for two angles. Number one for 0 degrees or 0 radians, or for pi radians, because that's a negative 1 comma 0 and that's 1 comma 0. Remember, sine is the y coordinate in the unit circle. So in this case, we can call it a solution for, well, let's actually, well, I'm gonna do that in a minute. Let me do the next one. Sine equals to negative 1/2. Okay, actually positive 1/2. So sine is positive in the first quadrant and the second quadrant, and that's actually the y coordinate. The y coordinate. What's the x coordinate? Root of 3 over 2. Root of 3 over 2. So in this case, well, that's, I believe, that's a pi over 3 and 2 pi over 3, because I believe we already did this one. Let me double check the notes, the one that had the sign. No, I don't think we did this one, so this is new in a way. So let's see. So yes, this is the angle right here. So from here, I'm going to be in the need of doing actually 4 generating solutions. 1 for 0, 1 for pi, 1 for pi over 3, and 1 for 2 pi over 3. I didn't mean to say generating solution, actually general formulas for solutions. So let me do the one for the first. For the sine equals 0, that's theta equals 0 plus 2 pi k, which reduces to simply 2 pi k. And we already did something like this in the previous example, remember? 0 to 2 pi k. The only solution is going to be good for k equals to 0. And then we're going to do theta equals to, okay, so that was 0 radians and pi radians. So that's pi plus 2 pi k. Well, this one doesn't reduce at all, and then in this case theta equals to 2 pi times 0, which is 0. K equals to 1. Well, that's going to give us 2 pi. But this one is outside of the range, so goodbye. Call it a day for that one. Now let's do the theta equals to pi plus 2 pi times 0. That's simply pi. Alright, and then for k equals to 1, theta equals to pi plus 2 pi times 1. That's 2 pi plus pi, that's 3 pi. But 3 pi, clearly it's a number that is larger than this 2 pi. So far we have two solutions, 0 and pi. Alright. What's next over here? Now we're going to do the general formulas for the solutions for pi over 3 and 2 pi over 3. I believe these two we already did, but let's just do that again. So for theta equals to pi over 3 plus 2 pi k, and pi over 3 plus 2 pi over 3 plus 2 pi k. Theta equals pi over 3 plus 2 pi 0. Well, I should have just written 0. That's simply pi over 3. That's one solution. And then theta equals pi over 3 plus 2 pi. Oh, actually 2. That's 2 pi over 3. K equals to 1. Let's see, what do we get about k equals to 1? Theta equals pi over 3 plus 2 pi times 1. Well, that's going to go over pi over 2 because that's 2 pi. I mean, not pi over 2, actually pi over 2 pi. So 2 pi plus something, it's 6, 7 pi over 3. Clearly, this is going to go past the solution. That past the range, actually. Theta equals 2 pi over 3 plus 2 pi times 1. And that's going to give us, well, 2 times 3 is 6 plus 2, that's 8. And again, clearly this solution is outside of the range. So let's write down the solutions within the 0 to 2 pi range. In this case, we got 0, pi, pi over 3, and 2 pi over 3. Let's write those down from smaller to large. If we put this together, that's going to be 0, pi over 3, 2 pi over 3, and pi. Alright, let's look at the last page. Couple of examples in this case. So let's see. What do we have for the last couple of pages? Well, notice in this case we have a cosine equation. We already did a cosine, by the way. But this one has a square, and in this case it's one in which we're going to use the square root property. So let's solve for cosine squared theta equals to 3, and then divide both sides by 4 to get cosine squared theta equals to 3 over, actually 3/4. Okay, to get rid of the square, we need to take the square root on both sides, but be careful here, because every time we take the square root, well, in this case, the plus minus, it's going to be important here. And then we're going to take the square root of 3, which is simply the square root of 3. And then the square root of 4, which in this case happens to be 2. Alright, what are we going to do in this case? Well, the same. Let's draw a Cartesian plane. And in this case, well, we're looking for, because of this plus or minus here, we are essentially looking for both solutions. One, the negative root of 3 over 2, and the positive root of 3 over 2. Alright, so in this case, we're going to use the 4 quadrants. Alright, the 4 quadrants. Alright, so where the x coordinate equals to negative and positive root of 3, that is negative, actually this is positive root of 3 over 2 comma 1/2, root of 3 over 2 comma 1/2, and then the negative x, negative root of 3 over 2 1/2. negative root of 3 over 2, 1/2. What are those angles in which we are going to have this these values for? In this case, it's the x only. I mean, I'm writing the y coordinate as well, just so you can look up on the unit circle. All right, and then compare. So in this case, we're gonna have pi over 6 5 pi over 6 6 pi over 7 pi over 6 and 11 pi over 6. So we are going to have essentially 4 general formulas for the solutions. In this case, I'm going to write them vertically, not horizontally, for space purposes in this case. So we have everything together here, and yes. So okay, let me fix this real quick. All right, so number 1, the first formula is going to be pi over 6 plus 2 pi k. Again, 2 pi k because these solutions are periodic every 2 pi units, and then 5 pi, pi over 6 plus 2 pi k. 7 pi over 6 plus 2 pi k. And 11 pi over 6 plus 2 pi k. Alright, so in this case, I'm gonna do this in columns. Instead of going k1, k2 horizontally, I'm gonna do it vertically. I mean, the idea is gonna be exactly the same. So I'm gonna do k equals to 0, okay? For k equals to 0, theta equals, well, plug in 0 here, you get simply pi over 6. Same here, 5 pi over 6. And then 7 pi over 6. Okay, this parenthesis was not supposed to be there. And 11 pi over 6. Let's do the same with k. K equals to 1. Well, if k equals to 1, if I plug in 1 here, I'm going to get 2 pi, 2 times 6, that's 12 plus 1. That's theta equals 13 pi over 6. Same here, 2 times 6, that's 12 plus 5. That's 17 pi over 6. And then 12 plus 7, that's 19 pi over 6. And 12 plus 11, that's 23 pi over 6. But did you notice something interesting here? All these values are outside of the range for the equation that we want to do from 0 to pi. So the only solutions are going to be theta equals this 4 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Alright. Final answer. Alright. So let's do the last example of this section for this video. Alright, so let me fix the camera here. So what do we have? Now we have a secant. We haven't done one that has to do with secant, and then especially this kind of weird looking angle. It's gonna be a fun one. It's gonna be. So how do we deal with secant? Well, number 1, let's use trigonometric identities, in which secant, recall that secant is the same as cosine provided you find the reciprocal of this value. Alright, recall secant and cosine are reciprocals. Alright, and now, well, let's do the usual Cartesian plane. So cosine is negative for two different angles. So actually we have it over here. We can use the picture from the previous example. Cosine is negative, oh well, actually negative a half, not negative root of 3, but it's actually quadrants 2 and 3. So negative 1/2 comma root of 3 over 2 and negative 1/2 root of 3 over 2, but actually negative. Alright, so in this case the angles are 2 pi over 3 and 4 pi over 3. Alright, so let's write down in this case the two general formulas for the solutions. So on the one hand, theta equals to, oh actually 5 theta over 2. It's the whole thing that gets set equal to 2 pi over 3 plus 2 pi k. And on the other hand, 5 theta over 2 equals to 4 pi over 3 plus 2 pi k. Alright, we need to solve for theta by multiplying both sides by 2/5, right? Same here, multiply by 2/5. Okay, so in this case we can cancel, 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 and in this case, well, let's see. 2 times 2, that's going to be 4 pi. 5 times 3, that's 15. And then plus 2 times 2, which is 4 pi k over 5 equals to theta. And for the second general solution, theta equals to 2 times 4, that's 8. 3 times 5, 15. Plus 2 times 2, that's 4. Alright, 4 pi k over 5. Okay, so here is where the fun begins. So let's start generating solutions. These are the general formulas. Let's do k equals to 0. So for k equals to 0, theta equals 4 pi over 15 plus, well, plug in 0 here, essentially you get 0. 4 pi over 15. That's our first solution. For the second general formula, k equals to 0, 8 pi over 15 plus 0, because if we plug in 0 here, that's 8 pi over 15. Alright, k equals to 1. K equals to 1, well, this one is going to make us work a little bit, not much, plus plug in 1, 1 times 4 pi, that's a 4 pi. Let me put the 1. And in this case, well, you want to combine these two fractions together. Well, multiply by 3, divide by 3 to have the same denominator. So our final answer right here is going to be something over 15. 3 times 4, that's 12. 12 plus 4, that's going to be 16 pi. And then over here, theta equals 8 pi over 15 plus 4 pi over, oh, actually times 1 over 3. Well, actually not, that's not over 3, it's over 5. Okay, let me make this look like a 5. Let me fix this. Okay, that's a 5. So let's simplify this. 3 times 4, that's 12, plus 8. That's for 1. That's a 20. Pi over 15. But actually, this one reduces to 4 pi over 3. Alright, that's 4 pi over 3. Okay, let's do one more. K equals to 2 because 4 pi over 3 and 16 pi over 15, it's still within the range of within the interval 0 to 2 pi. So K equals to 2. For K equals to 2, theta equals 4 pi over 15 plus 4 pi times 2, this 2 over 5. And then let's just multiply, divide by 3 to get the same denominator. So 3 times 2, which is 6 times 4, that's 24. 24 plus 4, that's 28 pi over 15. Yes, the numbers are starting to look a little bit wacky in comparison with the ones that we had in the previous examples, but this one is going to work. This one is yet, so 28 over 15, that's still a little bit under 2. So you'll see what's going to happen here. So 8 pi plus 4 pi times 2. In this case, is this 2 for K over 5. And the same, I need 3 and 3. Final answer for this theta will be, okay, 3 times 2, which is 6. 6 times 4 is 24. 24 plus 8, that's 32. 32 pi over 15. And clearly, 32 over 15, it's bigger than 2. So this one, for K equals 2, we can actually disregard that solution for the second general formula. Let me do anyway K equals to 3. K equals to 3, you know, well, 28, it's only 2 pi over 15 away from 2 pi, right? So, but let's just double check. Theta equals 4 pi over 15 plus 4 pi times 3 over 5. Well, again, I need that LCD. 3 times 3 is 9. 9 times 4, well, that's 36. 36 plus 4, that's 40 pi over 15. And then 40 pi over 15 is clearly bigger than 2 pi. So we can disregard this one. What are we going to do here in this case? Well, let's call it a solution set over here. Theta equals, well, let's start with the smallest one. The smallest one was for K equals 0, 4 pi over 15, and then 8 pi over 15. And then for K equals 1, we had 16 and 20. 20 pi over 15. And for K equals 2, we only, well, actually this 20 pi over 15 reduced to 4 pi over 3. If we recall, let me write it down in reduced form. So that's 4 pi over 3. And finally, 28 pi, 28 over 15. And then over here, well, these two got away from the interval that we wanted the solution for. So in this case, we're done with this equation. Yeah, very tiny equation, very huge solution, very fun one, very interesting one to work with. Alright, so this is the end of this video. I think this is a good place to quit. I'll see you in the next video.